Okay, so in this topology we have two tunnel routers. We have R1 and we have R3, which are tunnel routers, and then we have R2, which is the LISP mapping database, which controls the control plane functions. So let's jump onto R2. We see we've got two sites, site 1 and site 2. Site 1 is an R1 and site 2 is an R3, and each of these sites is advertising an EID prefix. Let's go a little bit deeper now. Now you can see the EID prefix for site 1 is this address here, and it's been registered with a tunnel router known as ETR from this address here. This registration process happens every 60 seconds. Now if we jump back onto R1, which is a tunnel router for that site, we do a show IP int brief. We can see that the EID prefix is this address here, which is just a loopback address, and then its ETR address is here, and that's the router locator. And this is the thing about LISP, this local EID is separated from its routing identity, and the local EID is not reachable on the routing domain, but the RLOC address of 10.0.1.2 is. So if we go back to the control plane, we have a look at site 2, which is R3. We see more or less the same information with different variables. We have this EID prefix, and it's been registered to this ETR, which happens again every 60 seconds. If we jump over here to a show IP brief, we can see again here EID prefix, which is local to its site, which is not routable, and its ETR address of 10.0.2.2, which is here, is routable. Okay, so what I want to do is I want R1 to be able to ping R3. This is site 1 pinging site 3. And we need to source this from our address, from our local EID address, so the ping won't work. But firstly, let's just carry out a couple of commands. Let's do a show IP route for the remote EID. And if there's a routing lookup, you'd expect there to be a route in the table. There's nothing in the table for remote EID because it's local to that site. That's configured in R3. Let's take a look at the CEF table. Let's just go a little deeper. As you can see, the source is attached to LISP 0, which means it's capable of LISP encapsulation. So when it hits this IP address or this interface here, it's going to trigger the LISP process. Okay, so let's just do a debug LISP control plane. Let's just debug all here. Before anything comes up, let's just check the map cache. As you can see, we've nothing in the caching table for the remote EID. Okay, so let's just run a ping. What's come up here is a registration process that the tunnel router R1 is sending to the LISP mapping database every 60 seconds. Let's just run a ping here quickly before that comes up again. So 2.1, which is a remote EID. We have to source it from our local EID address. Let's just issue that ping. As you can see, quite a bit has come up on the screen here. Let's wait for that to settle. Yeah, so the first ping didn't go through, and that was ARP kicking in. But if you run that ping command again, we can see it's 100% success. So what I want you to look at here is this map request. So this tunnel router is sending a map request from its local EID to remote EID. Okay. What's important, it's receiving a map reply message. If you look at the address, it's receiving a map reply messages from 10.0.2.2, and it's using the port numbers that are assigned to the LISP 4342, which is UDP port number. And this address here, 10.0.2.2, is actually the RLOC assigned to the tunnel router R3. So what's happening, once the tunnel router R1 registers with its LISP mapping database R2, and you want to send a ping. Once the registration process is complete, the LISP map middays forwards the map request to R3, which directly replies to R1 itself. Now let's have a look at the map cache. Okay, now we can see we have an entry for 192.1.2.0. Okay, and let's have a look at the Ceph table. Let's quickly just look at the routing table. 192.168.2.1. As you can see, as we expected, there isn't a route lookup for that specific prefix because it's local to site 2. Let's just quickly check the Ceph table out of interest to see what type of information we have here. And the detail command on there will give us a bit more info. Now, this is different than the output from the Ceph command before we ran the ping. As you can see, we have a next hop of 10.0.2.2. Now, this next hop is the next hop of the RLOC in the other side. So the two sites are communicating directly without actually using the LISP, without actually forwarding to the LISP control plane or actually using this control plane of R2. Now, if we issue another ping of 2.1, and we're going to source it from our local ID, this ping goes through 100% successful, and as you can see, you should run the debug. Before I did that, debug LISP control plane. Oops, so debug this control plane off. Now run the ping again. So we've run a ping from site 1 to site 2. And as you can see, no debug outputs coming up because it doesn't need to perform the registration process anymore because everything is now, it's in its map cache.